Remember, the sp3 hybridized orbital is technically 75% p and 25% s. In other words, remember, he's 1 part s and 3 parts p. Since he has more p than s character, he takes on the shape more like a p orbital than he does a spherical s orbital. Doing the same analysis on the sp2 hybridized orbital, he would be technically 67% p and 33% s, simply because he's a third s and 2/3 p. So he's still more p than he is s, but he has more s character than the sp3 hybridized orbital, so he's a little shorter and more blunted. And lastly, the sp hybridized orbital, of course, is half s and half p. So, in summary, the sp3 hybridized orbital has the most p character, and the sp hybridized orbital has the most s character, which is why he's the shortest and most blunted out of the 3 hybridized orbitals. That means that if you're an atom that's sp hybridized, since your orbitals are more shorter, that means your bonds are going to be shorter, and that's why the bottom molecule with the sp hybridized carbons would have the shortest bonds, and the top molecule with the sp3 hybridized carbons would have the longest bonds. And of course, the bond for the sp2 hybridized carbons in the central molecule would be in between the two extremes. But this is not the only thing that hybridization helps us understand. We could also understand the relative strengths of these bonds. Notice the trend here. The top molecule has the weakest bonds, and the bottom molecule has the strongest bonds. And again, don't memorize this. Why is this so? We could understand this. Remember, the top molecule carbon-carbon bond is an sp3 overlap, where the bottom molecule has an sp overlap. Again, because the relative sizes and shapes of these orbitals, we can make sense of bond strength. Notice in the top bond we have this much overlap, and in the bottom bond we have this much overlap. We can clearly see that the bottom bond has more overlapping of the orbitals, and the top one has less overlapping. And remember, the more overlap you have of orbitals, the stronger the bond, and therefore the less overlap would give you a weaker bond. So again, hybridization